In the last class, we have discussed about basics of waveguide, different modes in the waveguide, and different waveguide parameters. Today, we are going to discuss about the scattering matrix and microwave components. The outlines of today's lectures is to understand significance of scattering matrix, then microwave T-junctions. Directional coupler and isolator and circulator will see in next class. The basic objective is to understand the need of applying circuit or network concept to handle microwave analysis and design problems, to know the significance and application of scattering matrix, and to analyze the microwave T-junction. So basically we have studied the two-port network, and these two-port network are based on the low frequency circuit analysis, and we have studied the network parameters such as Y parameter, Z parameter, ABCD parameter, and these parameters are used to study voltage and the current relationship between two different ports. When we are going to study or to understand the power relationship in microwave components, so the two port low frequency circuit analysis cannot be applied, because here the electrical and the magnetic field they exist. So we have to find out the relationship between the electrical and the magnetic field between different ports, and for that we have to apply the Maxwell equations, and it is difficult to apply Maxwell equations and to find out the whole electrical field and the magnetic field. So the easy the network analysis called as a scattering parameters are used to find out the relationship between the different ports. These scattering parameters are used to give the power relationship between two different ports, like the uh, Y parameter, H parameter, ABCD parameter in two port network. So in different these microwave junctions, so we will use scattering matrix. So let us take an example of microwave junction. So it is a junction where the two or the more than two ports are meeting at a point. So a 4-port network is shown in the figure: port 1, port 2, port 3, port 4. So basically, so this scattering matrix gives the relationship between the incident power and the reflected power, and based on the incident and the reflected power, we'll find out the scattering parameters. So this is the one is an example shown, 4-port network. This is another here shown that the source is connected at the port 1 and the loads are connected at the port 2, port 3 and port 4. We have studied maximum transfer power theorem. If the load is connected to the characteristic impedance, there is no the reflected wave. If it is connected to the characteristic impedance, maximum power transfer will take place and no reflected power will be there. If there is a mismatch of the load other than the characteristic impedance, the reflected power will be there, and the combination of the incident and the reflected power will give the standing wave pattern. And these scattering wave parameters are studied using the standing wave patterns. Now this is, as I told you, for the two-port network, which will give the relationship between the voltage and the current, relationship between the two different ports, and you can find out the voltage and the current. And if we want to find out the powers, we will use the scattering parameters. So now take an example of a scattering matrix which consists of the n number of ports, and let us assume that the source is connected to the ith line and loads are connected from the first, second up to the nth line except ith line, and all the loads are connected, that is ZL is not equal to Z0 or ZL is equal to 0 to the different lines. If you see the AI, this is the incident wave, the source which is giving the incident wave AI, and the BI is the total reflected wave, which is the combination of the first to the nth line, is called as the reflected wave. So when it will come at the junction, so this incident power is splitted into the A1, A2, like the AN, etc. And if the load is not connected to the characteristic impedance, there will be reflected power from the B1, port 1, port 2 up to the port N, and the reflected power occurs. So the standing wave pattern will occur, and from that the scattering matrix are uh, uh, generated. So now let us take two cases. In the case 1, So same, the micro junction is there. So there are the n ports, the source is connected to the ith line, and uh, loads are connected from the first to nth line except the ith line. And in the case 1, the first line is not terminated to the Z0, that is Z0 is called as a characteristic impedance, and all other lines are terminated to Z0. It means that when the first line is not connected to the Z0, there will be reflected power will be there, which is called as your the P1. And if all other lines are connected to Z0, there will not be reflected power, all the power will be absorbed. So therefore B2 up to the Bn is equal to 0. The total reflected power, that is a Bi, is equal to B1. So therefore the relationship between the incident and the power, and incident power and the reflected power, is given by the equation Bi is equal to Si1 into A1, where this Bi is called as a reflected power, A1 because that is the first line is called as the incident power, and the Si1 is called as a scattering parameter, which gives the relationship between the reflected and incident powers. So Si1 subscript I shows that the source is connected to the ith line, and the 1, that is a 1, it shows that it is a reflection from the first line. Accordingly you can understand. So therefore the B2 B3 up to the Bn is equal to 0. The scattering matrix for this case is given by Bi is equal to Si1 into A1. Bi is the reflected power at the ith line, Si1 the I is the source connected to ith line, 1 is a reflected power from the first line. So this is a scattering matrix. So if you understand the subscript I, and that is a 1, that may be called as a J. I is a source connected to that ith line, and the J is a reflection from that jth line. So in the case 1, if you understand, you can understand the case 2. Now let us take example of the case 2, where all the lines n-1 lines are terminated in impedance other than Z0. It means that from every line there is some reflected power will be there, the standing wave pattern will be generated. Now if you take the example of all the lines are not connected to Z0, so the source is connected to the ith line, then this Bi is given by, that is a Si1 into A1, where the I is the source is connected to the ith line. The one is called as the power reflected from the first line, power reflect Si2 power reflected from the second line, Si3 power reflected from the third line, the Sin power reflected from the nth line, and the A1, A2, A3, An are the incident waves to the specific ports. And if you assume that the source is connected from the 1 to nth line, that is I goes from the 1 to n, and since I can be any line from the 1 to n, so therefore we can write by putting the values of the I from the 1 to n, we will get the n number of equation, that is the B1 is equal to S11 A1 plus S12 A2 plus S13 A3 plus S1 A1 An. Like the Bn is equal to, like just you go on putting the values of the I from 1 to n, we will get n number of equations. So there are, so this is like the all the n equations can be represented in the form of the matrix form. So like this matrix form, you can write the B1 B2, which is called as the reflected waves, A1 A2 An are called as the incident waves, and this is the n by n matrix, which will give you the scattering parameters. So that is a n by n matrix. S11 power connected to the first line and power reflected from the first line. So accordingly you can understand. So like this, you can, to understand this S11 S12, so let us remember Sij, the corresponding to the scattering coefficient resulting due to the input at the ith port and output taken out of the jth port. Sii denotes how much power is reflected back from the junction into the ith port when input is applied to ith port. So in general, you can write the equation like the B is equal to S into A, where B is a reflected matrix, A is incident matrix, is called as a scattering matrix. So this is a very example for the n by n port. So you can represent the scattering matrix in the form of incident and the reflected waves. And from this scattering matrix, you can find out the power, incident power, as well as the reflected power. So this is a scattering matrix. And every this scattering matrix have the properties, because many times the question was asked state and explain the properties of the scattering matrix. Basically, this scattering matrix are used for the microwave waveguides to find out the relationship between incident power and the reflected power. Now let us see the properties of S matrix. The first property is this scattering matrix is always a square matrix of the order n by n. If there are the 3 ports, this matrix will be 3 by 3. 4 ports, it will be 4 by 4 matrix, and so on. So it is always square matrix. The second property is always symmetric matrix, that is Sij is equal to Sj. That is called as a symmetric matrix. It is unitary matrix. S into S complex conjugate is equal to the identity matrix, which is called as a unitary matrix. The fourth is the sum of the product of each term of any row or column multiplied by a complex conjugate of the corresponding terms of any row or the column is always zeros. And fifth, if any of the terminal or reference plane are moved away from the junction by an electric distance, that is a beta k and lk, each of the coefficient Sij involving k will be multiplied by the factor e raised to minus j beta k lk. So the first 4 properties are very important. They are used to find out the relationship between incident power for the different ports for different type of the T junctions. So you have to apply the scattering matrix to find out the relationship between incident and the reflected power in various T's. Then, as I told you, the microwave power is propagated through waveguide. Many a times it is required to connect 2 sources or the combine the 2 microwave power to your single, that is line. So that time the different type of the T's are required. Sometimes it is required to split the power. Sometimes it is required to take part of the power for the measurement from the main line. So that times you cannot cut the microwave waveguide abruptly. So you have to use the different components. So these components or these are called as a microwave T's, or these are called as a microwave the junctions. So accordingly, basically 3 type of microwave T's are there. These are called as a H plane T, another is called as a E plane T, third one is called as a EH plane T. Now let us see how this H plane T, E plane T and EH plane T junction, that is the looks, and we have studied the performance of H plane T, E plane T, EH plane T in my practicals. Now let us take example of the H plane T. In case of the H plane T, so basically, so the microwave waveguide is cut at, that is a wider part of the waveguide, and a part of the waveguide is connected to that wider part. So this is called as a H plane T. So basically there are the 3 ports. So port 1, port 2 and the port 3. So the magnetic field is symmetric along at the port 1 and the port 2. It is also symmetric at, that is a port 3. And this H plane T, as I told you, if it is a 3 port, it will result 3 by 3 scattering matrix, and this 3 by 3 scattering matrix can be written in this form. And here we have to apply all the properties of the scattering matrix to get the relationship between incident and the reflected waves. It has a plane of symmetry of the junction, so therefore S13 is equal to S23. S13 is equal to S23. From the symmetric property also we can write Sij is equal to Sji. So S12 is equal to S21, S23 is equal to S32, S13 is equal to S31. So you can write the scattering matrix as like this, and the port 3 is perfectly matched, that is S33 is equal to 0. By using these properties you can write, and we will use another property, S into S complex conjugate is equal to I. We will write this, there is a matrix, and we will get the equations, and we will multiply rows and column. We will get equation that is from the 3 to 9. You can study it in detail. And if you see, so by solving all the equation, we will see the B1, B2 and the B3. We will get the incident power from the port 1, port 2 and port 3. Also we will see it in the next class.